So, dear students, welcome to the session of NEET Bytes. On behalf of Meritnation, I welcome everyone in the session of NEET Bytes. I hope all of you are doing good. So, hello Meghna, Aditya, and Pooja. Welcome to the session. Hello DJ Bros and the other students. Welcome to the class. So, today we are going to talk about alternating current. We'll take up some of the questions of previous year NEET papers and we'll see the solution of them. So yes, the first question. An inductor of 20 millihenry, a capacitor of 100 microfarad, a resistor of 50 ohm are connected in series across a source of EMF of voltage given by this relation. The power loss in the circuit is, we have to find the power loss. You should understand one thing. In an LCR circuit, if you talk about an LCR circuit, in an LCR circuit, mainly the power loss is because of the resistor. Okay. So here we have 20 millihenry and 100 microfarad capacitance and 50 ohms of resistance in the given circuit. So voltage source is having peak voltage to be 10. So 10 sine of 314 into T. So if you compare this given relation with the standard relation for AC, you can say that V is equal to V naught into sine of omega T, where V naught is the peak voltage and omega is the angular frequency of the AC. So omega here will be equal to 314 radians per second, and your V naught, that means peak voltage, is 10. So in LCR circuit, if you talk about, the power loss is given by this formula. The power loss will be given by I Rms squared into capital R, where I Rms is the Rms current. This is Rms current. So first of all, we'll find Rms current. Okay, how can you find the Rms current? First of all, you should understand that what is Vrms? Vrms is equal to V naught by root 2 for the AC, right? And next thing is IRMS. IRMS is equal to Vrms over the impedance Z. So ultimately, you'll get the formula as power loss is equal to Vrms square, Vrms by Z square into R. So next thing we have to find is the Z. See, Vrms is clear. V naught is 10. So that's equal to 10 by root 2 volts. So substitute the value here, 10 by root 2, 10 over root 2 square divided by Z square into R. So how can you find the value of Z? Oh, Arindam, happy birthday to you. So yes, Z is equal to under root of R square plus omega L minus 1 by omega C whole square. This is the way we calculate the value of Z. In the given question, omega is how much? Omega is 314. And L is how much? L is how much? It's equal to 20 millihenry. So 20 into 10 to the power of minus 3 Henry. And C is how much? It's 100 into 10 to the power of minus 6 farads. So dear students, if you substitute the value of these three things and your resistance, and resistance is equal to how much? It's equal to 50 ohm. So when you put the values here, you'll get the value of Z to be equal to 56. Z will be equal to 56 ohm. You can calculate that. Next thing, we have to find the P average or average power dissipated. Just put in that formula that I have just written over here, this formula. So yes, Vrms is 10 by root 2, 10 over root 2, or we can just take 10 by root 2 here into 1 by Z square, 56 square into 50. So ultimately, you can find the value of power to be equal to 0.79 watts. Okay. So I hope you're able to understand this. So the correct answer for the given question is A. Let's move to the next question. Okay, the question is, which of the following combinations should be selected for better tuning of an LCR circuit used for communication? So which circuit has a better, tuning in communication system? The one having more quality factor will have good tuning. So if you focus over here, we have to find the quality factor for each of the given combination. So how can we find that? What is quality factor? If you see the formula for quality factor, it's given by omega naught L by R, and that can also be written as 1 by R into root L by C. See, it can be even the capacitive reactance also. It can also be like this, 1 by omega C into R, where omega naught is equal to 1 by root LC. So by that, we get this formula for quality factor, 1 by R into root L by C. So we will put these values of resistance, impedance, inductance, and capacitance. We'll get the value of quality factor, and from the quality factor, the value which is maximum will be taken as the final answer. So if you substitute the values here, so Q1, if you calculate from the first part, if you calculate, yeah. So 1 by R, 1 by 15 into under root of L, that means 3.5 divided by 30 into 10 to the power of minus 6. So this is the quality factor for first one. If you calculate the value, you'll get the value to be 22.7, something like that. Next thing is for Q2, for the second part. For second part, you can put the values here, 1 by 25 into under root of, it's 1.5. Obviously, it's very obvious to see that option B is having lower value as compared to option A. So yes, it's 45 into 10 to the power of minus 6. And that, if you calculate the value to be set, it will come to be 7.3 approximately. So yes, for the quality factor of third type of circuit, you can say that Q3 is equal to 1 by 20 into under root of 1.5 into 35 into 10 to the power of minus 6. Obviously, this one is also lesser than that of first one. So if you calculate the value, you'll get the answer to be approximately 10.35 for this. And for the next one, for the last one, Q4, if you calculate the value, you'll get 1 by 25. Just observe this, 1 by 25 into under root of 2.5 divided by 45 into 10 to the power of minus 4. So sorry, minus 6. And that's equal to 9.4. So when you compare all these values, you can find that this one is the maximum. So as this is maximum, this circuit is best suitable circuit for the communication, for tuning in communication system. So that's why the correct answer for the given question is A. Here's the other question. The potential differences across the resistance, capacitance, and inductance are 80 volts, 40 volts, and 100 volts, respectively. An LCR circuit, the power factor of the circuit is, so what is power factor? If you know, the power factor is given by cos of phi, where phi is the phase angle, where phi is the phase angle. So, and see, and what is, how can you find the value of tan phi? Tan phi can be found by this formula, XL minus XC by capital R. XL minus XC by capital R, where XL is the inductive reactance, XC is the capacitive reactance, and R is the resistance of the circuit. So just in the given question, XL, XC, and R are not given, but we are given with the values of inductance, sorry, the potential difference across the inductor, across the capacitor, across the resistor. So how to do that? How to do this question? So if you observe, if you multiply numerator and denominator with I, the current, or IRMS, if you talk about IRMS, so you can get that it becomes IXL minus IXC, and this one becomes IR. So what is this? Actually, these are the voltages across the capacitor, inductor, and resistor. So IXL is how much? IXL, that means the voltage across the the inductor, voltage across the capacitor, and voltage across the resistor. Substitute the values here. VL is how much? It's equal to 100, and VC is how much? It's 40. So yes, substitute the values here. 100 minus 40, and VR is 80. So what do you get from this? What do you get from this? 100 minus 40 by 80. So you get 60 by 80 from this, or you can say it's 3 by 4. So tan phi, we got the value to be 3 by 4. We have to find the value of cos phi. So how to find the value of cos phi from the value of tan phi? Just remember this. If in a triangle, if you take this angle as phi, and this is 3 and this is 4, obviously by Pythagoras theorem you can say that it's 5. So yeah, if tan phi is equal to 3 by 4, so very obviously we can say cos phi is equal to 4 by 5. And that means the answer is 0.8. The correct answer for the given question is A. So I hope it's clear to all of you. Let's move to the next question. Yes, the question: a series RC circuit is connected to an alternating source. Consider two situations. First, or A, when the capacitor is air filled, B, when the capacitor is mica filled. So mica is a kind of dielectric substance. Mica is what? It's a type of dielectric substance. And you should understand that the dielectric constant for mica, K, is more than 1. For air, we take the K to be equal to 1. The dielectric constant. I hope you're able to understand that. So current through resistor is I, and voltage across the capacitor is V. So how to compare the two voltages in the two situations? We are having, see, what is V? V is the voltage across the capacitor, and I is the current through the resistor. Okay, so how to compare the voltages in situation A and situation B? Okay, you are saying it's A equal to AB. Okay, let's see. First of all, we'll make an RC circuit. This is R, this is C. Suppose V is equal to V naught sine omega t. Now, if you focus over this, you can find the value of current. See, you can find the value of current by this formula. V by Z. Okay, V by Z. So just focus over this. How can you find the value of Z? Z is equal to under root of R square plus XC square. XC is the capacitive reactance. So X is given by 1 by omega C. And what is the value of omega? Okay, it's not given. So we can say Z is equal to under root of R square by plus 1 by omega C whole square. So when you just calculate this, you will get it to be equal to omega C R square plus 1 under root of omega C square. This is the value of Z. Now if you find the voltage across the capacitor. So what is the voltage across capacitor? See, the voltage across capacitor is given by this formula. I times XC, where XC is the capacitive reactance. So that's equal to 1 by omega C. And we have found the value of I, and that was equal to this value. Sorry, this was the impedance. So V by Z was the value of that. So V divided by under root of omega C R whole square plus 1 into omega C into 1 by omega C. You can find that the voltage across the capacitor is given by this formula. This is the voltage across capacitor, and that's given by this formula under root of V by under root of 1 plus omega C R whole square. So just try to understand that when the capacitance, see, when the air is there inside, the capacitance, let's say C. When we have mica here, if we have mica here, if the K is the constant, the dielectric constant for that, we can say C dash will be equal to K times C. Obviously, K is greater than 1. So that means the capacitance in the case of mica is more than that of capacitance when the air is there. So by this, we can say that the voltage, now see, the voltage across capacitor is inversely proportional to C. More the capacitance, less the voltage. So this means voltage in case of air is more than voltage in case of mica. So VB means voltage in case of mica. That means the correct answer for the given question is C. So I hope it's clear to all of you. Let's move to the next question. Yes, the other question. A resistance capital R draws a power P when connected to an AC source. If an inductance is now placed in series with the resistance such that the impedance of the circuit becomes Z, the power drawn will be. So yes, in this case, what is given to us in the given situation? First of all, a resistor is connected across the AC supply. And let us say V is equal to V naught sine omega t is a source voltage. So what is the power? The formula for power is given by this IRMS times VRMS. Okay, VRMS into IRMS. Next thing we can say, how can we find the value of IRMS? IRMS is equal to VRMS by R. So IRMS is equal to VRMS by R. So we can say P is equal to VRMS square divided by capital R. This implies P times capital R is equal to VRMS square. Let us take this as the first equation. Now talking about the second part of the question. The second part of the question says that if an inductance is now placed in series, so we have to find the power. So given that when the inductance is placed in series, the impedance is Z now. The impedance is Z now. Okay, the impedance is down to Z. So what is impedance? Z. Okay, so yeah, power dissipated will be given by this formula, VRMS into IRMS, VRMS into IRMS into cos of phi, where phi is the phase angle, and cos phi can be written as R by Z. So what we can do, we can just replace this IRMS by IRMS is basically given by VRMS by Z. So we can say P is equal to VRMS into VRMS divided by Z into cos phi, that means R by Z. So what do you see here? You can see P times VRMS square divided by Z square into capital R. So from the equation 1, we have seen that VRMS square was equal to P into capital R. So we can put the value here. So yes, VRMS square is equal to PR. So sorry, let's say this is P dash. The power is P dash here. So yes, so P dash is equal to PR divided by Z square into capital R. So this becomes PR square over Z square. So this is the final answer for the given question. So what is the answer for this? Obviously the answer A is the correct answer for the given question. So I hope it's clear to all of you. So in this way you try more questions. So if you are preparing for NEET, just do more questions like this, then it will be perfect. So thank you so much, students. So to know more how we can help you, you can see the given link. Okay, so thank you so much. All the very best from my side, and a very happy new year to all of you.